Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good morning, ladies and gentlemen, and welcome to the Schriever Spacepower series. I'm Kevin Chilton, Explorer Chair for the Mitchell Institute's Space Power Advantage Center of Excellence. When the Space Force was established, its leadership recognized the importance of technology and innovation. So it established a new type of office in its staff, the Chief Technology and Innovation Office, to lead advanced initiatives, maintain awareness of emerging opportunities and challenges, and shape the direction for the Space Force adoption of new capabilities and practices. To discuss the dynamic technology opportunities and challenges facing the Space Force, we have with us today Dr. Lisa Costa. As the Chief Technology and Innovation Officer for the Space Force, she is responsible for developing strategy and policy to advance science, technology, and research, and the employment of cutting-edge technology to digitally transform the Space Force. So with that, Dr. Costa, I'd like to extend a warm welcome to you. It's great to see you again. And thanks for taking time out of your busy schedule today to join us in the forum. And let's begin by giving you an opportunity to provide any opening remarks to our audience.
Well, thank you, sir. I really am quite honored to be asked to return to the Mitchell Institute. There is much to talk about. There is a lot happening in the Space Force, and just to give a little bit of background about who I am and answer the question, why is she the CTIO? My background is in computer science. That's what my PhD is in. And my background is in big data, AI, modeling, simulation, and analysis, and enterprise risk management, really leaning more toward the cyber perspective. And when you think about that, it's really a stage setter for this conversation, I think, because why was someone with my background as opposed to perhaps someone with a degree in aerospace engineering is in this position. So with that, I want to talk specifically about the threat and China's approach to space using artificial intelligence and machine learning in particular, and how they're applying that to autonomy. So space, AI, and quantum are the three key areas that China has determined to be their top technology priorities. The Pentagon, in a new report to Congress, is warning the Chinese are focused on dominating in AI to probe enemy vulnerabilities and advance the concept of intelligentized war. The PLA envision AI technologies, including orbital platform in space that can make decisions on who is and isn't an adversary based on AI. China is projected to spend $14.7 billion this year alone on AI. And in 2 short years, in FY26, that is expected to almost double to $26 billion. That's an extremely large investment. And not only are they applying that to AI research, they're applying it to the operationalization of AI. So this also applies to robotics, swarming, and applications of AI that, when put together and used from a convergence perspective, really provide a counter space capability. The PRC argue that the increasing frequency, complexity, and the risks of space missions raise the need for incorporating AI and autonomy to support and protect China's space assets. They see promise in AI and autonomous applications for space robots. So for example, you may have read in April, they did a experiment where they said that they allowed an AI to take over one of their satellites and for 24 hours to operate without a human in the loop. that wasn't exactly completely true. What they allowed was an AI to control the camera that was on the optical satellite, but not the satellite operation itself. But indeed, that experiment was really interesting in terms of what it looked at. And it looked at two primary areas. One was an area in Japan where the US has aircraft carriers, and the other was an area of between India and China where there have been skirmishes. So we can see that that's kind of a historic look from an AI perspective. The real key will be when we can move toward more real-time training of these large language models, and then how that will apply to being able to control different sensors and sensor webs. So a common problem, though, that cuts across all of these areas, not only for China, but for us as well, is the amount of data that we have and the quality of data that we have. So I fundamentally believe, though, that this is going to be a solved problem very quickly. And why do I believe that? Machine learning and natural language processing is at a point now that computer-based tagging of information, large amounts of information in real time, is possible. And in fact, computers are much better at tagging and marking up data than humans are, right? They're much more consistent, at least. And so I believe this is going to be a real game changer in terms of being able to use AI in the operational space. The real key is who will implement reliable, secure, and trustworthy AI. And of course, you know that we do have a program, and there was an executive order that was put out last Monday, in fact, articulating the need for responsible AI across the United States. So we have a number of teams working in responsible AI areas. The key will be to understand when those limits are off, what could potentially happen, and how our adversaries might use that. Since the end of 2015, China's on-orbit presence has grown by 379%. So that represents a number of 709 satellites in space by the end of April of this year for China. And over 360 of those are ISR satellites. So they have a number of phenomenology equipment on those satellites. They're able to collect an immense amount of data. The question is, are they able to process that amount of data? They have been doing experimentation in terms of on-orbit computational processing and AI algorithms. So I think this is something that's very interesting and really sets the stage for why someone who is a computer scientist is really working as the CTIO in Space Force. So with that, let's
That's
chat.
a great introduction. You hit on a lot of topics that I wanted to ask you about today.
Okay.
But if I want to start at a really fundamental question, it was part of your introduction that we gave you. And it's something that I think General Raymond came out and said early on in his tenure as the first Chief of Space Operations, that the Space Force was going to be the first digital service. Can you help our audience understand what that means?
Absolutely. And I will say that vision is still forming, right? But we have implemented a number of capabilities to ensure that as the first service developed and built within the digital age will be digital. And we are actively working to remove tech debt that we inherited as part of our systems, but also working to.
Now, let me interrupt. What do you mean by tech debt? Yeah.
So for example, a lot of people think that because we're a new service, we just got all new equipment, right? We're able to start from scratch and blue sky everything. Well, that's not quite true, right? We had GPS satellites up, we have a number of constellations up, and many of them run on different networks. Many of them run on older networks, and so. Working to modernize those capabilities is absolutely critical because it's very difficult to build incredibly advanced AI, modeling and simulation, digital twins on top of old infrastructure. It just simply won't run. It wasn't built to have that amount of data throughput and processing. So fundamentally, we're looking at fixing the foundation, and then we are also, though, upskilling our guardians, creating supercoders, and I really want to talk about supercoders because I think they're really a part of our secret sauce, and then allowing that combination of modernization of the foundation with the real-time changes to capabilities by supercoders. That is a huge game changer. And by the way, CTIO name is game changer. So I thought I'd throw that in for branding there. But supercoders are critically important to Space Force. They are not just coders. I can buy coders. They are guardians first. They have been trained usually in at least one operational area, and they're an expert in that operational area. But many of them have been cross-trained in a number of different operational areas. They self-select then to become a supercoder. And this is really a commitment by them and their commander, because you don't build a supercoder overnight. You send them to 3 months of immersive coding school, and then you send them to a 3-month internship. So, I get calls almost every day from commanders saying, how do I get me some supercoders? And the answer is, well, this is the process. However, oftentimes we're able to kind of pull together some supercoders to work on critical capabilities. But the issue is that the supercoders are experts in space. They are experts in space operations, and they are able to put hands-on and make changes with other operators in a multidisciplinary team and make changes in real time. And that's really the critical differentiator for supercoders. So making a digital service is all about being fast and having an organizational structure that allows innovation at the edge, bring that innovation into the enterprise, and then push out more capability to do that edge-based innovation.
Got it. Now, space traditionally has been very, and I might say this, I mean, civil, commercial, military space exploits have been pretty risk averse, typically because of cost, the amount of effort, and everything that goes into from cradle to grave, from launch to on-orbit operations to deorbiting a satellite system. The expense and the time invested is not an environment that encourages a lot of risk-taking. Is that important to the Space Force today to kind of flip that a little bit and be a little more aggressive with regard to risk-taking? And if so, how is that enabled by the work that you're doing?
It is. It is indeed the approach the Space Force is taking in that, and we understand we're taking a hybrid approach, right? You have very bespoke, very expensive systems. You're not going to just change the baseline code on those. However, we also have low-cost commercial capability that we're augmenting those bespoke systems with, or that they're individually doing things unique within those constellations themselves. So we are focused on ensuring that the right changes can be made in the right time to get actionable effects to the joint services. So that's critical in terms of being able to make those changes and to incorporate OTTI, right, operational training, test, and evaluation into the change-based system. And that is being developed by STARCOM. So it is a very integrated and deep partnership between headquarters, its field comms, and its direct reporting units to accomplish this end-to-end pipeline of delivering capability quickly based upon partnering operators with acquirers with developers.
Got it. Okay. So ostensibly going to be quicker and more flexible, a little more risk-taking, but not on the really expensive must-have systems that are critical, say, for deterrence operations. Okay, I got it. One of the challenges I can recall from the past was we'd come up with new languages, computer coding languages for a program. That program would run for 8 years, and in the interim, a new program would come along with a new language, and then you couldn't find coders to do the original program. And it was just, it was incredible to me how we would snap a chalk line and say, no, you must use this language, then we'd change, and you couldn't find anybody interested in the old language, for example. Are you faced with those challenges today as well? And how are you overcoming them with the supercoder construct?
That's a great question. We all remember COBOL, right?
And Ada. Ada was the one that I suffered through.
Pascal, Fortran 77.
Right.
You know, that happens all the time.
Yeah.
But we are using modern commercial standards.
Okay.
And that which e-commerce uses, that which, large automakers are using, for example, those are the types of tools that we are teaching our supercoders, that we are using, and that we are implementing. And so we have a number of software factories, DevSecOps, and we develop our code in a continuous improvement, continuous delivery, right, CI/CD pipeline. That really helps in terms of, well, first of all, not only bringing talent into the Space Force that may have already worked in industry, which is awesome, and they just bring that capability right into the service, but then training our people in commercial ways so that if they do leave, for example, the service, if they're in military uniform, their skills transfer automatically. So I think this is really a great approach for us because it fundamentally reduces cost. We don't have a bespoke software factory where we're using some code base or agile process that others are not using.
Okay.
It is universal.
Great. State of the art.
Yes.
You keep moving forward.
Absolutely.
Great, great. Hey, you mentioned data once or 10 times here along the way. And, it seems like commanders throughout history have oftentimes had too little data to support a decision. And probably more recently, oftentimes have so much data, they don't know which is the more valuable data. There's these comments you hear about most of the data ends up on the floor and not analyzed because there's just so much of it. So I know that's probably an issue you're focused on, and I'm curious as to your influence on data policy and where you think we are today and where we need to be to increase the agility of our operations in space and provide commanders not just data but actionable decision quality information.
No, absolutely. And my office has the chief data officer role for Space Force. We nest up under the Department of the Air Force, and then also, of course, the DoD CDAO. And we're also the chief AI officer for the service as well. We are focused on, right now, taking our unified data library that many people are probably very familiar with because we open it up to industry and academia at the unclassified level. So many people have used it to develop, prototypes and to test their systems. But we have created, I believe it's 176 new requirements for enhanced UDL. So we want to use AI to cleanse data. We want to have guardians be able to put data directly into the unified data library without having to go through a contractor, as an example. We want to reduce the backlog that gets created in systems that require a lot of human intervention, let's say. And so those requirements are very focused on how you bring in data, both data at rest and data in motion, process that data, and then determine what information is required by an individual organization and what we need to send on that comms pipe. Because if we have to send all of the data on a tactical comms pipe, that's not going to work.
Well, it'd be based on a query then. So I'm a commander. I query the system, and the system will provide me the slices of data and input that I need specifically, as opposed to everything or nothing.
Or it could be determined based upon your location automatically.
Okay.
So,
and your mission set.
Exactly.
Could be feeding my intel office
Absolutely.
And planners.
Yes.
And as quickly as that information is coming. Well, it's not just about having the data; it's about fusing it as well. How about your vision on that?
Well, so now we're getting to one of my pet peeves, which is dashboards. Dashboards are great if you're a NetOps person, right? And you need to look at 90,000 different elements to kind of see where your outages are and things like that. But if you're a commander in the fog of war, getting 90,000 pieces of data is not helpful. I only need to know the data that I need to know. And I also have to have a way of providing the data I've collected, maybe in a mission command perspective, back to the larger network, right? So others can use that. So it's about making data discoverable at the most tactical edge. And I know I'm from Space Force, and you would not expect a Space Force person to be talking about the very tactical edge, but that is what we're talking about, right? Space Development Agency, Derek Tournier, he is working at the tactical edge to ensure that warfighters have the space data that they need. My job is to make sure that that tactical piece is connected back to an operational and a strategic piece, so that we're taking all of that space data, we're processing it as closely to the point of origin as possible, and then we are distributing it, and we have a resilient approach to ensuring that that data is available globally.
Okay, very good. When you say tactical edge, I think most immediately think, well, it's the soldier in the foxhole on the front line, or it's the fighter pilot just about to be engaged or engaged in combat. Would you not agree that there's a new tactical edge in the space domain where a satellite system may be immediately in a very much tactical situation at risk because of an adversary satellite in its vicinity or some ground system that's just about to be deployed against it, and you need quick and real-time decision-making level data provided to commanders? Is that fair? The tactical edge has gone into space, not just in the terrestrial.
And that's a great point, because it is a point of debate. Do you allow a satellite to automatically detect threat? Or do you ensure that there is an operator in the loop to ensure that, to agree or not to agree? And sometimes the timelines for making those decisions are very small. So this is part of what we were working in terms of responsible AI and being able to make sure that we get the data and we get the decision at the right time. Some of that may include human on the loop as opposed to in the loop, meaning I've got an operator and they're watching. They may be controlling 20 satellites. So the human ability to kind of manage that number of satellites at any given time is very difficult. But in a threat situation where things are coming at that constellation, you may want to implement automation and just have the human watching that process and being able to stop it if required.
Got it. Thanks. AI/ML, you've talked about that a bit too, and how it can help the problems that we've discussed. There's benefits to it for sure if it's applied correctly, but there's risks as well. Could you maybe spend a little time talking about the risks and then how we intend to mitigate them going forward as you start using machine learning to inform commanders or make automatic decisions as you just described?
Absolutely. I mean, some of the risk, just off the top of my head could be that, if you did allow a satellite to maneuver based on what it may perceive as a threat, what wasn't a threat, you've now expended precious energy, right? And so you don't want to do that, right? That is a risk in the operational space. There's also the risk of, as I talked about, China developing capabilities to determine in real time using AI whether something is a threat or not a threat to a satellite, but it could be your own satellite, right? And so that's a risk as well. So, and then of course the maneuver that you use, you want to make sure that you're not creating debris. And that's absolutely critical for ensuring that space is usable for everyone. So when China does not make available their TTPs, their CONOPs for mission operations, that makes it very difficult because mistakes can be made, right, on everyone's part, and you don't want that. You want to make sure that space is usable by everyone in the future.
So how do you mitigate the risk you described with AI? Is it by finding the right level of human intervention into that or human oversight of the AI system or in space?
So there's two ways. One is absolutely having that human in the loop, on the loop, off the loop sort of approach. There's also, though, and I will spring on you an idea I have had but not really socialized with anyone yet, but you can think about training AIs to a degree that they have a, quote, rank, right? So you could actually think about an AI, and don't take this wrong, as a guardian AI, right? And it's an E7 or an E9 based upon the amount of data it's been trained upon, the types of data it's been trained upon, and how long it's been in use and trusted. And so you can start thinking about, because I think we're starting to get that way in our personal lives, right? People were using Alexa and Siri, and at first it was very, kind of playing games with it, and now people rely on, text to, or speech to text, text to speech, text to imagery. I suspect that is very much going to be the case as we get more comfortable with generative AI. I also believe that The interfaces that we're used to today, which is kind of typing in commands, will be much more using all of the senses, right? And so being able to use haptic devices for if you use Xboxes or like that to game, but also the speech to command capability, because that is a much quicker response than it is to type in a series of commands.
Right. Well, maybe BRINC isn't the right structure or analogy, because I've worked with some really smart people who are far junior to me. However, maybe children is the right structure.
Maybe that's it.
What you let your kindergartner decide on versus your middle school or high school.
Absolutely.
And an adult, or maybe two different or multiple different levels of decision authority as you go along. But I'm tracking what you're saying as you maybe control how much authority you're willing to relinquish to the machine.
Right.
Absolutely. Okay. You expressed a concern about China earlier, about the amount they're investing. I don't know what we're investing in total in this government, particularly if you looked at the commercial sector and national security sectors toward the problems that you're talking about and the needs to advance this technology. But how do we compete with a China that is as focused as they are today?
That's a great point, but I'll tell you, I am incredibly optimistic. And why is that? We have an amazing series of partnerships, and I don't mean just within the United States, because industry is developing capabilities. And some of the challenges we have right now with Gen AI, and let me just step back a moment and say, ChatGPT has only been with us less than a year, and look at the disruptive nature of the capability. We have incredible talent in Silicon Valley, across the nation, in industry, in our FFRDCs, in academia, and we're taking advantage of all of that. We have a number of 5, in fact, space science technology institutes that we're establishing, and we've awarded 2 contracts to date on that, where we are partnering industry with academia to develop products that we can buy off the shelf. But I also want to emphasize the fact that we have a number of critical partners in our international community, and they too are developing capability. We want to be the partner of choice for space, so that instead of developing individual bespoke systems, we are now agreeing on standards, not unlike the FAA and not unlike in the seagoing arena AIS, right? So if we are the partner of choice, we will have a space domain awareness capability that is shareable to everyone. And that's the approach that we're taking, and I think it's a much stronger approach than just throwing money at the problem.
And I've certainly in my history, I've seen how in civil space, U.S. civil space worked well with our European partners, for example, our Japanese partners, Canadian partners on the International Space Station. But that required us to all get together in a forum where we could all come to these agreements. Is such a forum been established for national security with our allies in the space domain?
So I would say it's emerging.
Okay.
We do have a group in our S5 that is international partnerships. In addition, in the CTIO office, we have the S&T partnerships, which also include international, as well as industry and academia. We're in a number of consortium that are developing standards, as an example. So I think that work is ongoing. Is it as mature as, the naval or the, air area? Not yet. but I think that's the direction that people are working towards, so that we can all have an environment in which our assets are safe and free from orbital debris and other hazards, because space is very hard and it is an inhospitable environment.
It is indeed. It is indeed. Let me take our conversation back, if I might, to data, other uses of data, and coding and machine or advanced computing. Modeling and sim. Modeling and sim capability, the ability to develop an artificial environment for people to train in and perfect their tactics, techniques, and procedures, or even become to understand the domain better as they mature into mature space operators, certified operators in the domain. Can you talk a little bit about how data is important to developing accurate models and sims, and how you're thinking about that, and also the advanced computational capabilities that we have available to us today that you probably didn't inherit, as you said, from days gone by?
Absolutely. So I just signed the digital modeling strategy for the service last week. So we are developing standards. That was done in conjunction with the field comms, with the DRUs, but then the broader DoD community as well. We are getting after standards for digital twins. So you would think with the use of digital twins by very large sectors of different industries, that there would be commercial standards out there, but they're not. They're very bespoke. So we're working toward at least an open standard where we can start to move models from concept, right? For example, from the Space Warfighter Analysis Center, SWAC, which does kind of mission design, moving that over to our acquisition elements that do costing and analyses of alternatives, and then moving that into our operational environment to kind of get, yes, this is what I wanted, or no, this is not going to help. And then that same model with more fidelity, as it kind of goes through this pipeline, is then able to be used for test, training, TTP development, etc.
Wargaming?
Absolutely.
Yeah.
Absolutely. And so, in other words, what I always say is, we don't want a test pipeline and then a training pipeline, and all of it is the same pipeline.
Interesting. So start to finish, from requirement development in a good model, all the way through the acquisition process, to training, to operational exercising and wargaming. And then could you see it going one step further to actually be in a space operations command center in real time in a conflict, to be running those models in the background to help the commander decide what the next move might ought to be?
You could actually think about having a switch where I'm in simulation mode at one moment, and then in operational mode in the next. I think that what's important as well is really driving our development, our force design, by not limiting it and saying, well, we have this much money, ergo, this is the force design that we're going to develop. Instead, I think it's much more valuable to use what we are seeing, which is in CTIO, we do futures. And we look at 2045 and out. So these are the futures that are potential. Then modeling and simulating that capability to say, well, these are the futures that are most beneficial to the United States and its allies, and for free, space arena. then investing in those areas and letting that then drive the force design. You can do your analysis of alternatives, you know, in that process, but don't let, you know, the funding limit how you're thinking about what you need to buy for the future.
Okay, very good. Let me step back to education, training, and even go into recruitment. In days gone by when space was considered a peaceful domain and there were no threats to our space assets, and we had these very expensive systems up there. A lot of the backplane engineering supporting our operators in the field were with contractors, not with uniformed Air Force members. Now we're talking, I'm hearing you talk about, no, we're going to have uniformed Space Force members who are equally versed in how the system works and the software behind the space vehicles that they're operating, as opposed to having contractual support in the background. They're going to be in it. So does this make changes to recruiting policies that you can influence as the CTIO, as the types of expertise you need as we move away from, you know, pejoratively in some people's mind, a checklist approach to operating space systems to a warfighting approach?
Right. So absolutely. In fact, modeling and simulation is helping us get after what that force needs to look like.
Oh, really?
Indeed. So in CTIO, I have the S9, and that is the Modeling, Simulation, and Analysis group. We are working very closely with S1 to model what does the force need to look like, you know, 20 years from now. But then there needs to be an additional step, which is as we develop new systems and we're developing those models, we can then start to take a look at, well, what is the force structure that we need to operate that model? We need to look at it from a fully burdened system, right? The individuals coming in, what kind of training they need, what they will need to be able to do operations and maintenance on these systems. And you can really start to get after not just the objective force that you need, but the objective force you need to operate all the capabilities that you have and have built and that's needed. To
the ones you anticipate.
Absolutely, to support the joint force.
Right.
So I think it's absolutely critical that we continue on that vein. And I'm incredibly heartened by the amount of data-driven capability that we have been able to develop for the service.
Great. I have one last question for you before we go and invite our audience into the Q&A. You know, back in the 60s, we were doing hypersonic research. In fact, the space shuttle was a hypersonic vehicle, the X-15. And we had hypersonic programs looking at reentry vehicles. And then we kind of put all that on the shelf and didn't pay much attention to it for a few years until suddenly our adversaries started fielding hypersonic weapons. And we found ourselves behind technologically, if for no other reason, because the generations of engineers and scientists who had developed that technology had retired. I also remember in the 70s when I was new in the service, we had an airborne laser program down in Albuquerque, New Mexico, and we conducted several successful air-to-air tests with that, and seemed to be moving forward with directed energy technologies in the 70s and 80s, and then that disappeared from view. And the old saw was, you know, hypersonics and directed energy are just 5 years away. And every year they were just 5 years away, and the next year and so we kind of talked ourselves into believing that they would never really be fielded. And I would argue we got surprised when they were by our adversaries for our hypersonics. Are we in danger of that happening again with directed energy, where we were quite advanced, but it seems like we've stopped paying attention to it, and our adversaries have fielded capabilities? Both the Chinese and Russians have demonstrated laser capabilities that can hold our satellites at risk, and potentially. And certainly we see it as laser technology being used by ne'er-do-wells, shining them at commercial aircraft, even in our own country on occasion, with very low-tech directed energy systems that can cause problems for a pilot shooting an approach into landing, for example. Are we close to getting behind in directed energy?
I think there's always a danger of getting behind in any area, right? So I like to talk about the fact that in the government, we tend to manage science and technology together. These are two very different things, right? Mm-hmm. Science takes a very long time. You need exquisite knowledge. Technology are those things that we may not necessarily know why it operates, but it comes at us very quickly and is very disruptive. So I would say that in the area of directed energy, we had incredible benefit of being kind of the first developer and having that knowledge base. As you know, when you start talking about directed energy, it becomes very classified very quickly. But what I would say is that we are focused on defending our satellites and our assets from directed energy weapons that adversaries may be developing. And in addition, I would say that our capacity as a nation to generate knowledge and capabilities in areas that we may have had less investment in before, it is pretty capable of regenerating capability when needed, because we take a very multidisciplinary approach to science, whereas other countries don't necessarily. And I think that's important to understand, where you can kind of leap ahead in areas that you didn't think you had necessarily the knowledge in. But I will also say too, Space Force has a great relationship with the Office of Naval Research. And they're doing a lot of work, for example, in naval laser communications. We are, working with them in those areas. We're working with them in protecting assets for the Navy. So there's a lot of work going on, and that's probably about all I can say.
Okay, thanks for addressing that. Not knowing what's out there, I'm a proponent or in favor of multi-magazine, non-debris creating capabilities.
Absolutely.
That can hold our adversaries' constellations at risk in time of conflict and serve as a deterrent. And so it's good to hear that we're still investing in the areas of laser technology and directed energy technology and other means. So thank you. With that, I think it's the time to open up the floor for questions from our online audience out there. So Dr. Costa will be happy to answer your questions. And Aidan, if you will just relay the questions to us, we'll begin to address them at this time. Thank you.
Sure. First, we have a question from Mark Matthews.
Good morning, Dr. Costa. It's Mark Matthews. I instruct at the College of William and Mary, something some of my students are looking at, and I was interested in your comments, the analogy with AIS systems and the way we control aircraft in common airspace. Do you see us eventually evolving to a point in space which, much like now for autonomous aircraft, they have to have an ability to sense and avoid for both commercial and military systems?
I mean, I see that could be one way ahead. Of course, when you're talking about that, you have to have global cooperation, because it's not like anyone owns the space above them as opposed to airspace, right, over your geographic area. So that is something that could happen. And it certainly would help in terms of understanding space domain awareness and understanding free space.
Yeah, the other thing that's interesting about space is you may make a maneuver right now to avoid a collision, say, for example, and it could be done autonomously, perhaps in the future without human intervention. But you need to be thinking about 3 or 4 orbits later on, or days or even months later, of what other conjunctions or near collisions that could set up with another.
Absolutely.
So it kind of adds to your argument for the need for this incredible computing capability integrated with the ability to track satellites and know where they are and have those databases that would enable something like Mark just suggested.
Absolutely.
Great. And Mark, thank you also for both identifying yourself and your organization. I'd like to remind everyone to do the same going forward, and we'll take the next question, Aidan.
Next, we have a question from Frank Wolf of Defense Daily.
Yeah, great. Interesting discussion. I just wondered, just in terms of the Unified Data Library, I wondered if you could just sort of give an assessment of how BlueStack LLC has performed in sort of developing the UDL, and any updates to that development, and on the related advanced tracking and launch analysis system, Atlas. What is the latest in terms of the SPADOC replacement effort? The Senate Armed Services Committee has written that there were numerous deficiencies in that development, and there's been a de-scoping of the SPADOC replacement effort that was scheduled for the end of this year. So I wondered sort of what the current operational timeline is for Atlas and L3 Harris's and Omitron and Parsons Corp's effort on that, and if you could just give some thoughts on that.
Hi, Frank. Well, thank you for the question. And I'm not going to comment on any vendor's performance, both good or bad. I believe that. So first, you have to remember the UDL was it was a pilot developed by AFRL, right? So the design of it is quite old. However, it met the need at the time based on the amount of data that was being produced by the Space Force. That was not a lot of data. That was not, remember, we didn't have a lot of commercial assets. In fact, I don't think we had any commercial assets in space at the time that pilot was developed. So this is a new, time and place where we have massive amounts of commercial data being produced. And I will say, don't think of it as just commercial data being produced in space and from space. There's also commercial data about space being produced that needs to be processed as well. So that calls for a very different architecture and very modern systems that allow us to address different temporal aspects of data. So as you can imagine, those requirements for an enhanced UDL is very important, and that contract is supposed to be let in FY24. And you broke up quite a bit, so I didn't really understand the Atlas question.
Oh,
but
I'm sorry. Yeah, I just asked just about Atlas in terms of the Senate Armed Services Committee in its version of the Defense Authorization Bill this year said that Atlas has been de-scoped and that there have been numerous deficiencies in Atlas development, that the fielding timeline was supposed to be the end of this year, or was originally 2021. Now it's the end of this year and might have even slipped beyond that. But I'm just wondering, in terms of those deficiencies, I would imagine the machine-to-machine interfaces represent some of those. But I'm just wondering, they asked for an alternative if Atlas cannot be fielded. So I just wanted to get any thoughts you have on Atlas and where we are, where L3 Harris and Omitron and Parsons are in terms of trying to get that fielded, and if you can address any of those so-called deficiencies, a possible replacement if needed.
Well, I'll just admit right up front, Frank, that I have not read that report. However, I'm sure my team has. I'll take that as an action and be glad to get back to you. I'd be very interested in reading that report, but what I will say is that machine-to-machine interfaces are not nearly as easy as people believe they might be. However, I do believe that they are getting much easier based on having agnostic transport, and that's where we're really focused inside of Space Force, really focusing on, kind of a gray core or black core capability, and then you just add the encryption that you need. But getting it into formats that you need to do machine to machine, I think is going to be revolutionized by using AI and being able to develop almost in near real time the interface spec for the receiving machine to be able to take the instructions you're sending to it. But I will get back to you and take that as an action, Frank.
Okay, thank you.
There's some terms there I want to make sure everyone in the audience, UDL is...
Unified Data Library.
Okay, and so that's the library that says this is where everything is in space at this moment.
Yes, and it exists at multiple classification levels.
Okay. And then SPADOC I'm familiar with, and all the problems you just described about having machine to machine has been a problem with SPADOC, but of course it was, like you said, developed in a time period when there weren't as many satellites, there weren't as many risks. There certainly weren't adversarial risks in orbit. And SPADOC is really if I got this right, is the computer that looks at all that data and then predicts possible collisions, looks into the future and runs the orbital mechanics to determine where that satellite might be tomorrow, the next day, a week from now, a month from now. And if it looks like there's a collision that might happen, to let you know about it. That's
right, different models, right.
And SPADOC is old, but it worked adequately before the environment we're in today, where there's too many things for it to track at a meaningful period of time to provide accurate data to a decision maker. Is that fair?
Yes.
And also it has very strict formats which inhibit the ability of other sensors to even be applied to it to make it smarter. Is that fair?
Well, yes, and I would say it was never developed for commercial space.
Right. So they use different languages, different code, everything's...
Absolutely, and putting tens of thousands of assets up there, which is, I always like to say it's so important to do blue sky forecasting in terms of futures, because if we were to have sat around this table, in fact, 40 years ago, and said to ourselves, well, gee, what do we think that, space is going to look like in 40 years? 90% of what's happened would have been in the impossible range, not even in the improbable range.
That's so true. So true. Well, I'm glad to hear SPADOC there's an effort underway to replace it, because it served its time, but it's certainly not the tool that we need for the future. Would you agree?
I think that there are many things out there that are living extensive life spans that they were not meant to.
Life support, I think we call it.
Yes, exactly.
Okay, very good. Well, I think we have time for one more question, Aidan.
Sure. We have a question written in by Donald Peters. He asks, the skills you've identified for Guardians are also highly desirable in the commercial sector. Is retention becoming a growing concern for the Space Force?
A very good question. Believe it or not, with the models that we have developed looking at retention, it has not been a problem to date. However, I think that things change very quickly, right? And we have a lot of commercial vendors going into space that they are going to be very attracted to hiring Guardians. So we are looking at how to, as we invest a significant amount into each Guardian, regardless of their rank or where they're at in their careers. How are we going to keep them attached to and mission is critical, right? Contributing to the mission is always a really important part of retention in the military. But at the end of the day, look, a strong economy is a strong defense, right? I am not too worried about Guardians who will go into industry because they will then know what the Space Force needs, and they will be able to develop products at the end of the day that we will be able to buy and that will satisfy our needs better. So, you know, it's a give and take, and we're generating highly talented individuals. We're looking at STEM, but, you know, I like to say STEAM because I like to add the arts as well. It's very important in terms of the use of technology, and we are developing and churning out those people, but other organizations are doing the same, right? And we hope to benefit from their pipeline, their talent pipeline as well.
Well, certainly it's the mission that retained me in the service, and how much I enjoyed being part of that team. I think you're right on. The neat thing about this generation of Guardians is in uniform. They'll be able to continue to help in national security, but should they decide to transition out, the very skills that we teach them in the service, they can take to the commercial industry and still help in national security, which is a bit unique, to all the services. Dr. Costa, thanks so much for joining us today, and this is a great discussion. I hope our audience enjoyed it as much as I did. And ladies and gentlemen, unfortunately, we've come to the end of our Space Power series today. I want to thank Dr. Costa again for taking the time to speak with us. And from all of us here at MI Space, have a great Space Power Day.